Let's move ahead. Short-run production functions like the ones shown are often referred to as total product curves. They relate the total amount of output to the quantity of the variable input. Let's look at it from another perspective. The marginal product curve of a variable input.
What is this marginal product curve?
It is defined as the change in the total product that occurs in response to a unit change in the variable input. That is, all other inputs held fixed. A business manager like you, trying to decide whether to hire or fire another worker, has an obvious interest in knowing what the marginal product of labor is. If delta L denotes a small change in the variable input and delta Q denotes the resulting change in output owing to the delta change in L, then the marginal product of L, denoted MPL, is defined as MPL is equal to delta Q by delta L. Geometrically, the marginal product at any point is simply the slope of the total product curve at that point, as shown in the graph. For example, the marginal product of labor when L is equal to 2 is MPL2 is equal to 12. Likewise, MPL4 is equal to 16 and MPL7 is equal to 6 for the total product curve shown in graph. Note finally that MPL is negative for values of L greater than 8. Generally, a marginal product curve will be plotted at the bottom of total product curve. Note that it rises at first, reaches a maximum at L is equal to 4, and then declines, finally becoming negative for values of L greater than 8. As the production curve accelerates, the MP increases. As the production curve growth starts plateauing, that is, its acceleration starts decreasing, the MP starts decreasing. At the plateau point of the production curve, the MP reaches 0. Beyond this, the production curve starts diminishing, in which case MP also falls. The maximum point on the marginal product curve corresponds to the inflection point on the total product curve, the point where its curvature switches from convex, that is, increasing at an increasing rate, to concave, that is, increasing at a decreasing rate. Note also that the marginal product curve reaches 0 at the value of L at which the total product curve reaches a maximum. Looking at graphs, we may identify a range of values of the variable input that a rational manager like you would never employ. In particular, as long as labor commands a positive wage, such a manager would never want to employ the variable input in the region where its marginal product is negative, that is, L is greater than 8 in graph. Equivalently, he would never employ a variable input past the point where the total product curve reaches its maximum value, that is, where MPL is equal to 0.